enjoyable it is to be here among chemistry teachers after moving into the DC realm and not talking about Danielson or Park or Common Core or so. It's just, I love being with you guys. Right, Phil? Yeah. And I have to put in an unabashed, is that the right word? A plug for Phil's courses at Wheaton, not his courses, but Wheaton Orville South classes in modeling. I had a couple of teachers take those. They got them in biology, chemistry, and physics. It has transformed what they do in the classroom. And what Phil does up here, that's not an act. That's what teaching and learning is. When we talk about that modeling, kudos to Phil and what he developed out there. So we'll go do that. So
Spencer runs all that for us through Furman. So thanks to
Spencer too. In terms of that, and then we'll talk a little bit about Common Core. I teach at Downers Grove North High School. I'm the science department chair, and as the science department chair, I was in charge of helping develop the speaking and listening curriculum as part of Common Core this year. So why that happened? It was because we had 3 assistant superintendents who were asked to go someplace else to do their jobs, and so the department chair got put in charge of incorporating Common Core and ELA standards. So as part of that, the department chair, my colleague from South, Karen Etter, and I, we were on this team, and we took over the digital media portion of Common Core. And I think that was a good thing that we were on there because it makes you look at how do we get science students to speak and listen and read and write like scientists. If we always constantly have the English people telling us that we need to have kids read more, we could have, well, why? Well, let's get them speaking and listening and reading and writing like scientists. So this year in the gas laws units in our honors and in our regular, the teachers didn't teach gas laws. They put the gas law demos out there, the kids went around and investigated, we whiteboarded using some of the modeling approaches, and then each one of them made a presentation about their individual demonstration. They had to go look it up, they had to come back with the scientists. If you wanted the scientists, we didn't get big into the names this year, but we got big into that particle of, you know, why is P related to V? Why are T and B related? And I'll tell you what, the kids found more out on Google, and we had the help of the librarians. The librarians came into our classrooms to show the kids how to put together a good presentation, how to look up real resources. So I encourage you to try to do that as much as possible. Don't let somebody else tell you how to do speaking and listening and reading and writing. You know, be involved in that development of that. That's kind of my encouragement for that. So the kids found more. I saw a sign on Facebook the other day. I'm sorry I'm referencing that, but it said, Google will give you 100,000 responses. Your librarian will give you the right one. So utilize those people, right? So do that. I got this. This is a box that was given to me by Lee Merrick. And Lee's going to think I'm giving it. I do this in the class, so I just. But it's Boyle's Law, even though we call that. And I like this just because it goes off that whole particle theory. And some of you use the Vernier gas pressure sensors and have them make the graphs and so forth, and that's all well and good. But with the next generation science standards, we're getting into the science and engineering practices. And this, to me, that if you look at this bottle, this is the mind of Bob Becker, which is it's just absolutely brilliant thing.
I think that came from Walter Rohr, actually.
So it wasn't. Thank you. So I thought it was a Becker. Does it say?
I thought it was Lewis 95.
Lewis?
Yeah, Bob Lewis.
No.
So Walter Rohr. Bob Lewis was in Southern Cross last year. Sure. So what it is, it's a tire stem of a car that's put through the lid of the bottle. And here you got the syringe. This one happens to have a cap on it. You put some volume in there and you grease up the inside of that a little bit so it slides nicely. And then you put that in there, put the lid on. I did this the other night for Ken West. We were up at, where was that?
York.
I was in York. Okay, thank you.
I don't know where you were.
Lose your mind, become a department chair. So then what you do is you get some, and you can have a compressor in your room, you can do that. The lid popped off last week. See, like that. Don't do that. But anyway, you do that, and then what you do is you get a tire gauge. You have to take the volume there, and then they let a little bit of air out, write down the volume, write the pressure. Let a little bit of air out, find the volume, find the pressure. So now you got volume and pressure of that syringe as it goes up in there. And then they graph it. And the nice thing about this is, as they do this, okay, sure, they can see the graph, they start to look for a constant in there. And as you go through this constant, they graph it and they do the equations in there. What's very, very neat about it is when they're doing this, there's a missing piece. Because not only is the pressure from that tire pump going in here, but what else have to be concerned with. What else is pushing on this bottle? There's the atmospheric pressure. So they can actually calculate indirectly the pressure of the atmosphere that day because it's that added component to their graph. So they can mathematically come up with that. So this one really challenged the kids. I don't really give them that much. I have these made for my classroom, but as I look at this, if we look at the science and engineering practices, maybe we have kids do something like this, or maybe we just get it like this, but have them put something like this together, have their own pressure collecting device would be great. It's simple, it's an easy reset, and it's pretty darn analytical once you get to it. I have extra syringes and tire stems for anybody that's here that's new that wants to take this back and remember that you saw this. Thanks to Lee for passing this along. So I've got my set. So if you want one, see me after the thing, and I can give you some supplies. Okay? Boyle Law, analytical.